Hello students, welcome to this ROSE project which is conducted by Rate Shikshan Samsthas at HGM College Karad. Myself Mohite SS. Today we are going to study a new topic, binomial distribution. Let us see binomial distribution. This is our lecture number first. The weightage of this topic of this board exam is 5 marks. Next, let us see content of this topic. First point is Bernoulli Trial. Second point is binomial distribution. And third point is mean, variance and standard deviation of binomial distribution. Before we starting this topic, let us see one example. First example is a coin is tossed twice. Find the probability of getting at least one head. Next, solution. For finding the probability of getting at least one head, first we have to find a sample space S. If we tossed a coin one time, then we can get the possible outcome is first is head, second is head. Then next, if we coin tossed second time, first is possible outcome is head, second is tail. Next, first is possible outcome is tail, second is head, and last outcome is 2 times tail. Therefore, number of sample space is equal to 4. Now let us consider an event A which is getting at least one head. Then possible outcomes in that event are 2 times head, second is head and tail, third one is tail head. At least one head means minimum 1 and maximum 2 heads are to be there. Next one, therefore number of A is equal to 3. Then probability of that event is equal to number of event divided by number of sample space, that is equal to 3 by 4. If here asked the probability of getting no head, then the probability of that event is 1 by 4. Then next example is a coin is tossed 10 times. Find the probability to get heads at least 5 times. Here a coin is tossed 10 times, then we have to find the probability of to get heads at least 5 times. Means that solution is here we have to use the formula is n of s, number of sample space, is equal to 2 raised to n. Here n is 10, therefore 2 raised to 10 is equal to 1024. Here we cannot find sample space this type, hence therefore we can use this formula 2 raised to n, that is equal to 2 raised to 10 equal to 1024. Such a type of examples we can use a binomial distribution. Now next point is Bernoulli trial. Let us see Bernoulli trial. Trials of a random experiment are called Bernoulli trials if they satisfy the following conditions. First is there are finite number of trials. Finite number of trials means if we coin tossed 2 times, 3 times, 4 times, 5 times, that is the finite number. Hence, therefore, the trials are the finite number of trials. Second, trials should be independent. Means that if we coin is tossed one time, then we get a possible outcomes. First is head, second is tail. Means that first outcome is head, second outcome is tail. Next one, if we coin tossed it second time, then a possible outcomes is first is tail, second is head. That is trial should be independent. Next one, third point is every trial will have only 2 outcomes, that is success and failure. Here if we coin is tossed 2 times, then possible outcomes are head head, next one head tail, that is first one is success, second is failure. Means that head is a success, tail is a failure. If we have to say tail is success and head is a failure, then next point is the probability of success and failure remains same in each trial. That is if we coin is tossed one time, then with possible outcomes are first is head, second is tail. And also if we coin is tossed second time, then possible outcomes are first is tail, second is head, then there are two probabilities. Then the outcomes of that probability is 1 by 2, means that the probability of success and failure remains same in each trial. Next one, let us see example. A coin is tossed 10 times is a case of 10 Bernoulli trials in which each trial result in success, say heads, or failure tails, and the probability of success, say P, is same in each trials. That is, P is equal to 1 by 2, means that the probability of that success is 1 by 2. Then next one, therefore Q is equal to, that is probability of failure, means that here the probability all possible outcomes is 1. Therefore the probability of failure is 1 minus P, that is equal to 1 minus 1 by 2, is equal to 1 by 2. Therefore P plus Q is equal to 1. It follows the sum of these probabilities as expected is 1. Next point, let us see binomial distribution. Consider the experiment of tossing a coin in which each trial result in success, say heads, or failure tails. Let S and F denote respectively success and failure in each trial, means that here we denote a success by S and failure by F. Now let us see one example. A coin is tossed 3 times, that is 3 Bernoulli trials. Here the finite number of trials, that is 3 Bernoulli trials with probabilities P and Q equal to 1 minus P for success and failure respectively in each trial. Therefore, the sample space of the experiment is the set S equal to, if we tossed a coin 3 times, then the sample space of that point is 3 times head, next one 2 times head, 1 time tail, head, second time tail, third time head, next one 1 time tail, 2 times head, next one head, 2 time tail, next tail, head, last time tail, next 2 time tail, third one head, and last possible outcomes is 3 times tail. That is, here we denote the probability of that success is S and probability of that failure by F. Therefore, here we can write this sample space as H as replaced by S. Therefore, 3 times S, next one 2 times S, 1 time F. Here probability of that head is S, probability of that tail is F, next probability of head is S, next tail by replaced by F, 2 times head replaced by S, HTT by SFF, THT by FSS, FSF, TTH by FFS, and 3 times T is replaced by 3 times F. Therefore, the number of success is a random variable x and takes x values 0, 1, 2 and 3, means that here is no heads. Therefore, the possible outcomes is only 1. There is only one head. The possible outcomes are FFS, FSF, SFF, F. That is, next one is possible outcome. If getting the heads are possibility are 2, FSS, SFS, SSF, and next one possible outcomes, there is 3 times heads, that is only one possible outcome. Now next, the probability distribution of the number of success is as below. P of 0 heads, that is equal to P of x is a random variable, that is x is equal to 0, that is P of no success. There is no success, that means no heads, 0 heads, that is P of probability of FFF. Here the trials are the independent, then we can separate the probability, that is equal to P of F into P of F into P of F. since the trials are the independent. Here the probability of failure is Q. Here put the values of probability of failure Q into Q into Q, that is equal to Q cube. It can be written as, here the coefficient of Q cube is 1 into P raised to 0. Any possible number raised to power is 0, then it has value 1. Therefore, it can be written as P raised to 0 into Q raised to 3. Here, 1 is the number of outcomes, P raised to 0 and Q raised to 3 are the probability of each outcomes. Therefore, P of x equal to 0 is equal to, it can be written as 3C0, P raised to 0, Q raised to 3. Now next, probability of one success, that means one heads, that is equal to probability of x equal to 1, that is equal to probability of SFF, FSF, FFS, that is equal to probability of SFF plus probability of SFF plus probability of FFS. Here the trials are the independent, then we can separate the probability. Therefore, P of S into P of F into P of F plus P of F into P of S into P of F plus P of F into P of F into P of S. That is equal to, here the probability of success is P and probability of failure is Q. Therefore, we can put the values of probability of success and probability of failure, that is equal to P into Q plus Q into P into Q plus Q into P, that is equal to P into Q square plus P into Q square plus P into Q square, that is equal to, here the addition of 3 times PQ square, that is equal to 3 into PQ square. Here the 3 is the number of outcomes and PQ square is the probability of each outcomes. Therefore, P of x is equal to 1. That means probability of one success, that is one head, it can be written as 3C1 P raised to 1 Q raised to 2. Next one, probability of two success, that is equal to probability of x equal to 2. That is, there are two heads. Therefore, P is equal to P of probability of SSF, SFS, FSS. Next one, probability of SSF plus probability of SFS plus probability of FSS. That is equal to, here the trials are the independent, then we can separate the probability. Therefore, P of S into P of S into P of F. P of S into P of F into P of S plus P of F into P of S into P of S. That is equal to, we know that the probability of success is P and the probability of failure is Q. Then put the values probability of success and probability of failure, that is equal to P into Q plus P into Q into P plus Q into P into P. That is equal to P square into Q plus P square into Q plus P square into Q, that is equal to, here the addition of 3 times P square into Q, that is equal to 3 into P square into Q. Here the 3 is the number of outcomes and P square Q are the probability of each outcomes. Therefore, probability of two success can be written as probability of x is equal to 2. In this form, 3C2 P square into Q raised to 1. Next one, probability of 3 success, that is equal to probability of x equal to 3. That means there are 3 heads. That is probability of SSS. There is only one outcome, that is equal to, trials are the independent since we can separate the probability. Therefore, P of S into P of S into P of S, that is equal to P into P into P, that is equal to P raised to 3. Product of this 3 times P, P cube. Here we can write this P cube in terms, here the coefficient of P cube is 1 into P raised to 3 as it is Q raised to 0. Here the value of Q raised to 0 is 1. 1 is the number of outcomes and P raised to 3 into Q raised to 0 are the probability of each outcomes. Therefore, probability of 3 success can be written as P of x is equal to 0, P of x equal to 3 equal to 3c3 p raised to 3 into q raised to 0. In general, we will the probability of x success in n trials where x could be any integer 0, 1, 2, 3 up to so on n. One of the way in which we can have x success is to have success on the first x trials and failures on the remaining n minus x trials, as here we can given n trials and x success so that the remaining n minus x trials are the failures. That is, here the x trials are the total x successes and the n minus x trials are the total failures. Therefore, the probability of these outcomes is probability of x success into probability of n minus x failure. It can be written as p raised to x into q raised to n minus x. Now, there are NCS outcomes each having x success and n minus x failures, as this is the number of way of picking x trials out of n for success to occurs on them. Thus, we have the formula probability of x success is equal to NCX p raised to x into q raised to n minus x, where x is equal to 0, 1, 2, 3 up to so on n and q is equal to 1 minus p. That is, probability of random variable x is equal to NCX p raised to x into q raised to n minus x. That is, it can be written as nx p raised to x into q raised to n minus x. This p of x is called the probability function of binomial distribution. Now next one is definition. A discrete random variable x is said to follow a binomial distribution with parameter n and p if PMF is given by p of x equal to x, that is equal to NCX p raised to x into q raised to n minus x, where x equal to 0, 1, 2, 3 up to so on n, and the probability which is lies between 0 to 1 and q equal to 1 minus p, and second condition is 0 otherwise. Now let us start examples based on the binomial distribution. Our first example is, if a fair coin is tossed 10 times, find the probability of getting A exactly 6 heads and B at most 6 heads. Let us see solution of that example. Let consider x is equal to number of heads. Therefore, the probability of that coin tossed shows a head denoted by P. Therefore, probability is 1 by 2. Therefore, Q is equal to, we know that the formula 1 minus P. Here put the values of P. 1 minus 1 by 2 is equal to 1 by 2. Therefore, we can get Q is equal to 1 by 2. Here we have to given n is equal to 10. Here coin is tossed 10 times, then the value of n is 10. Therefore, x follows binomial distribution with parameter n is equal to 10, p is equal to 1 by 2. Therefore, the PMF of x is given by p of x equal to x is equal to NCX p raised to x into q raised to n minus x. By this formula, p of x equal to x is equal to 10cx 1 by 2 raised to x into 1 by 2 raised to 10 minus x. Here we put the values of p and q and the value of n, that is equal to 10cx. Here 1 by 2 raised to power has positive x, and here the power of 1 by 2 is 10 minus x, then plus x minus x get cancelled, then remaining term is 10cx into 1 by 2 raised to 10, x is equal to 0, 1, 2 up to so on 10. Now first we have to find exactly 6 heads, that is probability of x is equal to 6 is equal to 10c6. Here we put the value of x is 6, that is equal to 10c6 1 by 2 raised to 10 is equal to, by the formula of combination, here we use the formula NCR, that is equal to n factorial upon r factorial into n minus r factorial. Then it can be written as 10 factorial upon 6 factorial into 10 minus 4 factorial into, here the power of 1 by 2 raised to 1 by 2 is 10, then 1 upon 2 raised to 10, that is equal to 10 factorial as it is, 6 factorial into 10 minus 4 factorial is 4 factorial into 1 upon 1024. That is equal to, when we solving this term, then we can get 210 upon 1024, that is equal to 105 upon 512. Therefore, probability of x equal to 6 is equal to 105 upon 512. Now next we have to find at most 6 heads. That is, at most 6 success x less equals 6. Therefore, probability of x less than or equal to 6 is equal to 1 minus probability of x greater than 6. Here we have to find 1 minus probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x equal to 9 plus probability of x equal to 10. Here 1 minus probability of x equal to 7, we can put the values 10c7 1 by 2 raised to 10 plus 10c8 1 by 2 raised to 10 plus 10c9 1 by 2 raised to 10 plus 10c10 1 by 2 raised to 10. Here in each term 1 by 2 raised to 10 is common, therefore we can take it term 1 by 2 raised to 10 common. 1 minus 1 by 2 raised to 10, remaining terms are in the second bracket 10c7 plus 10c8 plus 10c9 plus 10c10. When it can be solved, 1 minus 1 by 2 raised to 10 means that 1 upon 1024. Here for solving this term, by combination formula, 10c7 the value is 120, 10c8 the value is 45, 10c9 the value is 10 and 10c10 the value is 1. That is equal to 1 minus 176 upon 1024, that is equal to 1 minus 11 upon 64, then the value is 53 upon 64. Therefore, probability of x less than or equal to 6 is equal to 53 upon 64. Now let us see second example. A die is thrown 6 times. If getting an odd number is a success, find the probability of, first is 5 successes, second is at least 5 successes, third is at most 5 successes. Let us see the solution of that example. Let capital X is a number of successes, that is number of odd numbers. Here a die is thrown 6 times. That is, we have to find getting an odd number. Let us denote capital X, that is number of successes, and that is number of odd numbers. Let P is equal to probability of getting an odd number in a single throw of a die. Therefore, probability is equal to 3 by 6 is equal to 1 by 2. Since a die is thrown 6 times, then the possible outcomes are 1 to 6. Then the odd numbers is 1, 3, 5. Therefore, probability of that sample space is 3 by 6, that is equal to 1 by 2. And Q is equal to 1 minus P. Here we put the value of P, that is 1 minus 1 by 2 is equal to 1 by 2. Then the value of Q is 1 by 2. Here we given n is equal to 6. Therefore, x follows binomial distribution with parameter n is equal to 10 and p is equal to 1 by 2. The PMF of x is given by probability of random variable x is equal to formula is NCx p raised to x into q raised to n minus x. Therefore, here put the values of n. Therefore, probability of random variable x is equal to 6 is x 1 by 2 raised to x into 1 by 2 raised to 6 minus x is equal to 6 cx 1 by 2 raised to 6, where x runs from 0, 1, 2, 3, 4, 5, 6 up to 6. Now first we have to find 5 successes, that is probability of x is equal to 5 is equal to, here we can put the value of x is 5, that is 6c5 1 by 2 raised to 6 is equal to, by the formula of combination we can replace here n factorial upon r factorial into 6 factorial n minus r factorial, that is 6 factorial upon 5 factorial into 1 factorial into 1 by 2 raised to 6, that is 1 upon 64 is equal to, here we can solving this term we can get the value 6 upon 64 is equal to 3 upon 32. Hence the probability of 5 successes is 3 upon 32. Now next solution is at least 5 successes, that is probability of x greater than or equal to 5, that is equal to probability of, here the greater numbers are only 5 and 6, then we can addition of probability of x is equal to 5 and probability of x is equal to 6 are to be taken, that is equal to, by the formula of 6cx into 1 by 2 raised to 6, that is equal to, we can replace x by 5, therefore 6c5 is into 1 by 2 raised to 6 plus 6c6 into 1 by 2 raised to 6, that is equal to 1 by 2 raised to 6 into, here 1 by 2 raised to 6 terms to be common, then remaining terms are in the second bracket, 6c5 plus 6c6 is equal to 1 by 64 into 6 plus 1 is equal to 7 upon 64. Hence, the probability of at least 5 successes is 7 upon 64. Now, at most 5 successes, that is probability of x less than or equal to 5, that means 1 minus probability of x greater than 5, that is equal to 1 minus p, means that 1 minus probability of x equal to 6, that is equal to 1 minus 6c6 into 1 by 2 raised to 6, that is equal to, here we can solving this term, we can get the value is 1 and 1 by 2 raised to 6, we can get the value 1 by 64. Then 1 minus 1 into 1 by 64, that is equal to 1 minus 1 upon 64 is equal to 63 upon 64. Hence, the probability of at most 5 successes is 63 upon 64. Thank you.